So hello everyone, my name is Shahir and welcome to our Ansys Spaceclaim workshop hosted by UTDL. Um, Before I begin, I'd like you all to try and log into your ECF account, and it's because we will be having an interactive component later on in this workshop. And before I move forward, I'd like to hand it off to Kyle to just speak about UTDL for a bit and just talk about what's coming in the next couple of months.
Yeah, thank you, Shahir. I'm Kyle. I'm the technology director here at the University of Toronto Design League, or UTDL, accompanied by Yash, who is also a tech director. And
Hey
we
guys.
also have another tech director, Andrew, who is not here at the moment, but may pop in a little later. So UTDL has all about bringing people from the digital workspace to the physical workspace. So the tech team we put together workshops being in CAD, Ansys, different modeling programs, Arduino, bringing up into 3D printing as well. That way we can showcase you from the digital to the physical workspace. These workspaces are for everybody to attend. They're to help you in real life situations, scenarios, group projects, or projects and assignments in school, as well as just in your day-to-day life. If you want to try building something, we're trying to help build the backbone and fundamentals of the physical workspace on how to do that and how to transfer you to get first digital and physical prototypes for your solution. So UTDL also holds mini events and designathons. These mini events are usually about a week long and usually CAD based. And we're also holding our weekend designathon. Even with COVID, we're holding it online. It will still happen about the first week of February. So please stay tuned for that. Follow us on social media. And all of our workshops are recorded and will be posted on our YouTube channel, utdl.tech, and will also be made available on our website. Thank you very much. And Shahir, I'll pass it back to you.
Thanks, Kyle. So the purpose of this Spaceclaim workshop isn't to get into the nitty-gritty of Spaceclaim, to go in depth into what the program is like ultimately about, but rather it is to sort of get everyone's feet wet in the program, because I believe that Spaceclaim, Ansys Spaceclaim, is a very intuitive program. And once you start using it for the first time, for the first couple of times, once you start using it for your own design projects, it'll naturally come to you and you'll learn just more and more about it and you'll just become more knowledgeable. So this workshop is really just to get you introduced to the program. And if you're just wondering, the length of this workshop should be around an hour, so not too long. So because this is an introduction to Ansys Spaceclaim, I also thought it would be nice to go over the general importance of CAD. You know, why do we need CAD in our engineering design projects? Why should we prefer that over, laboring and making physical prototypes all the time? And one thing that I like to say is that in this day and age, especially, where you can't meet up and make physical designs, physical models, it's a great alternative to go on a CAD program like Spaceclaim, like SolidWorks, and work with your team virtually, if they're across the world and whatnot, and make a model with valid simulations to present to your prof or to your client and have an almost equal solution, standing. So that's why I wanted to also go over that importance of CAD. So just to go briefly over the agenda, like I said, I'll be going over the motivation behind CAD. And then I'll open up Spaceclaim and you guys can follow along with your program or just watch, and I'll just show off the interface of Spaceclaim, just what generally is Spaceclaim and whatnot. I'll then try and make a simple object while showcasing all the various features, all the most important features that you may be using for Ansys Spaceclaim. And then near the end, I'll leave you guys to do an exercise, making your own bracket in a set period of time. And during that time, I'll also be helping answering any questions and helping you guys out if need be. And then if you guys want to stick around, we can also I'll be open for questions near the end. So let's start with the motivation behind CAD and Ansys. if you haven't seen, I'm gonna turn off my camera for the remainder of this presentation because I don't trust my internet enough for it to stay stable. So I'm just gonna cut my camera here for now. Um, so this diagram, I don't like you might all be familiar with it. It is the engineering design process, which you may have seen in first year, or you may have forgotten if you've went beyond first year. In the middle, that cycle is what you call the project space. And it is where you and your team will spend most of your time formulating the solution to your project. In this workshop, I'm going to make the argument that the testing phase is most likely going to be the space where you're going to be spending the most time in, because you're going to be testing your model, gaining information, seeing if that information is valid, appropriate, gives some kind of solution to your project, and then you'll be going all over again. And I would also argue that getting out of the cycle can heavily depend on this testing phase right here. And to sort of drive in that point, I want to give an example. So say this is 200 AD, thousands of years ago, and you had the problem that you had a big backyard and you wanted to move your gardening supplies from point A to point B. You and your team get together, you go through the whole project space, and you come out with your first prototype to test, which is the first generation wheelbarrow. But when you test your first generation wheelbarrow as your first prototype, you find that the support can barely hold on to the wheelbarrow's weight, let alone any additional loads. And so what would you do in 280? You would go chop another tree down, maybe buy some more wood, carve up a new support, try and test it again, see some results again. Does it get better? Does it get worse? Yes or no? You just go through in a cycle over and over again, and what you end up losing is a lot of time, money, energy, and I would argue a bit of your sanity as well. So this is where CAD design comes in, where instead of jumping into your first prototype, your first physical prototype, you instead jump into a CAD program like SolidWorks and Ansys and design your model and simulate your model in those programs so that you can have a better first prototype and overall a better final design. In CAD programs, you can not only model your designs, but you can also perform heat transfer analyses, impact analysis, and fluid dynamics, and overall increase your productivity, improve your final design, like I said before, save a lot of time and money. You can simplify your sharing between your teammates who can be living across the world from you, and overall can save your sanity. But I would like to also put an asterisk on sanity because your proficiency in CAD programs can affect your sanity as well. If you're not proficient in the CAD program that you're using, then you may up losing a lot more sanity due to all the variability and errors that may come about when you're working with these kind of programs, which is why we have UTDL, which is why we have all these workshops laid out for you. So you can learn about these programs and be a bit more comfortable with them. So now that I've briefly gone over the sort of motivation behind CAD, I just wanted to go and outline how you can obtain Ansys on your personal laptop. You can go ahead and go follow this link, which will also be available in the HE, which I'll be providing later. And once you open this link, you just go ahead and press Ansys Student, check your system and browser requirements, and then go ahead and download Ansys Student. It's about a 6 gigabyte download, so give it some time. And the license also lasts for about a year. Thereafter, you'd have to reinstall the latest version of Ansys once again. It's all completely free. If you are on your ECF computers right now, all you have to do is type in SCDM to open up Spaceclaim. So while you go ahead and try and open up Spaceclaim, I'm going to go ahead and give you a minute and post the HE in the chat. At the end of this workshop, the HE will also be released to everyone via email. So I'll give you all just a brief 30 seconds or so. Okay, let me just check. All right. So, like I said, I'm just going to be going over the most popular features that you'll be using in Spaceclaim. Before I get into that, I just wanted to go over the basic interface that you'll be working with Spaceclaim. Just a little disclaimer. I, on my personal laptop, have a updated version of Ansys Spaceclaim, which isn't much different from the version you may have on your ECF computers. The only difference is that for me, I would have to press the sketch mode before selecting my shapes to sketch. And if I want to exit sketch mode, I'd have to go through another tiny hoop to get out of there. But other than that, it is the exact same as what you may have in your ECF computer. I also want to draw a comparison to SolidWorks because I know many of you all might be familiar with that program as well. I would like to say that SolidWorks is regarded as like a feature modeler. And as in that it has a feature tree on the side where you can select and edit your individual inclusions or your features. For example, if you made an extrusion halfway through your modeling process, you can go in SolidWorks, you can go back to that extrusion feature and edit it if you wanted to. In Spaceclaim, you can't do that because Spaceclaim is what you consider a direct modeler, where whatever you do is set and can only be reversed by doing the reverse action. So if you extrude cut, you'd have to extrude fill or just fill or undo. And yeah, that's basically the sort of main difference between the two programs. So just the interface of Spaceclaim itself, I want to just showcase. You have your structure tree right here, which will basically showcase any planes or components that you might be having in this area right here. Below that, you have the options panel, which is going to be pretty important when you're working on your model. And you also have your properties panel, which is less important. It's mainly looking at just like minor things near the end of your modeling phase. So first, let's take a look at how we can change our units. To change your units, you'd go up to File, Spaceclaim Options, go to Units, and just switch, and you can go ahead and switch between metric, imperial, and lengths in millimeters, and meters, centimeters, etc., etc. So to start a sketch, on DCF Labs, you can just go ahead and start sketching, I believe. But for me, I would have to click Sketch Mode, and then I would have to select the plane that I have to that I like to sketch on. I'm gonna do the XZ plane. Just click on it once. Now I'm just gonna go over here to my sketching features, and just make a basic rectangle. I'm gonna click once, drag it, and I could just click it again, and I'll have my rectangle right there. But I'm gonna Control Z this, undo it. I'm gonna make the rectangle again and just showcase a little dimension feature that you can use in Spaceclaim. So you can see one of the dimensions is highlighted, and it is 27 millimeters. If I want that dimension to be, let's say 30, all I gotta do is just press 30. I don't need to type millimeters because Ansys already knows that. Whoops. What just happened right there? All right. So I can just go ahead and do that, type in 30, and it'll be right there. If I want to move on and edit my second dimension, I'll just press Tab, and it'll highlight my second dimension, which I can make, I don't know, let's do 20. And then once I'm done, I'll just press Enter, and I'll have my rectangle right there. Now, to pull my rectangle and turn it into a prism, or in other words, extrude my rectangle, I would go ahead and press the pull option, which is probably the most important feature that you'll be using in Spaceclaim ever. So what you just do is just press pull, and you just select the rectangle that you made, and you can basically click once, and then you can click again to drag to however you want, up and down, because that's the direction that I chose, or that's the direction that the sketch was made. If I let go, and you can see that the dimension is highlighted, I can go ahead and type in, let's say, I don't know, 20 millimeters, press enter, and now it's been extruded to 20 millimeters. I can also use the pull feature to do cuts in my object. For example, I'm going to try and sketch a circle on the top part of my rectangular prism. By doing that, to do that, I'm going to press select my face, select circle, and I'm just going to make an arbitrary circle right here. And now I'm just going to press pull once again and select my circle. And this time, instead of just pulling it, I'm going to, and you may have saw it already, but I'm going to go to my options tab and press cut. And this is basically going to ensure that wherever direction I pull, the material is going to be cut. So I'm just going to click and drag, and I'm going to drag it all the way through my body. And I'll know that it's gone all the way through when the little orange circle disappears. That means I've gone all the way through. All right, so I've made my cut. That's two things you can do with pull. But I'm just going to quickly showcase now how you can, view your model, because you're probably not sure if it's gone through or not. First of all, if you want to orbit around your object, you just press your middle mouse key or your middle mouse button, press and hold it, and you just drag your mouse to see, the cut and just the object itself. If you want to pan around your object, you press and hold Control and press and hold your middle mouse button, and you can drag it around like so. If you want to zoom, then you just gotta scroll your middle mouse button once again. And if you want to go back to a set view, like isometric, trimetric, whatever, you go to this top left Orient tab right here, and you can either press this button for trimetric or click on the drop down and go through the different faces that you would like to see right here. Okay. So I want to go, those are two things that I showed you with the pull feature. One is adding, one is cutting. With the pull feature, you can also do a bunch of other things like filleting, chamfering, pivoting, and much more. So if I want to do a fillet, for example, on a corner, I would go ahead and select my corner. I'll just select this for now. Press pull. And by default, if I were to drag the arrow, it would be a fillet, right? I can drag it once, see the highlighted arrow, and set my dimension if I wanted to. I'll just leave it at that. Let's see. If I wanted to do a chamfer or anything, I'll do the same thing for this corner. I'll press pull. And instead of immediately dragging, I would go once again to my options corner and see all the different options I have. One of them is a chamfer. So I'll click on that, drag it, and I have a chamfer right here. You can also do a pivot edge, like so. You can drag, set your dimensions and whatnot. And you can also, drag to extrude the edge to make a surface, or, copy the edge. These two aren't very prevalent. The main ones you may be using are the fillet, chamfer, and the pivot edge. These are probably the ones that you'll be using 98% of the time. All right, now say you have your object right here, and say you want to move it from point A to point B. If you want to move it not from 0, 0, but like somewhere else. What you'll do, what I'll have to do is I'll have to enable 3D Sketch and then end the sketch mode, but for you, the feature should already be here, all right here. So what you do is you just go to your structure tree. If you want to move your solid or each component or a component, press solid to have it highlighted and press the move feature. And now you can see all these arrows and rotations showing up. And now what you can do is you can just drag it to however you want. If I want to move it along the X, if I want to move it along the Z, if I wanted to rotate it. So that's where you can find the move feature if you want to move your object. In this whole section right here, you can also create planes. you can create a plane by first selecting a reference face. I'm going to just do this top face right here and click this one right here, this feature right here, plane. If I want to, move the plane away, I can also move the plane by just pressing move. Because I recently pressed the plane button, Spaceclaim has already selected the plane feature, and so I can just move the plane like so. And I'm going to set it at 15 millimeters. Now with this plane, I can make even more objects, with the plane being my reference point. And this can lead into, I guess, assemblies and whatnot if you want to make even more complex features on Spaceclaim. So I'm just going to arbitrarily, look at the plane from a top view. First of all, I'm going to select the plane. I'm going to go to sketch mode. I'm just going to do some random lines because they'll be useful later. I'll say that. I'll just do this, and I'll just do this, and I'll do that. And then if I don't want to make any more, I'll just press escape. And I want to add a curve to these lines. So I'm just going to go to the modify, and I'm going to do create a rounded corner. Yes, click on this. And wherever corners there are, I'm just going to click. Yeah, click once, and then I can just move my mouse a bit to create my bended corner, like so. Kind of gets a bit messy, but that's something you can do. All right. What I'm also gonna do is I am going to make, this is eventually going to show off some more advanced features that you can use with Pull. So I'm just gonna quickly make a circle at, let's see. Yeah, I'm gonna make a circle perpendicular to where this line is, like so. And what you can do with the pull feature is not only refer to your options tab, but you can also refer to these options right here for more sort of advanced pull options you can do. One pull feature you can have that's pretty important is the revolve feature, where all you have to do is once you click on it, is click on an edge or an axis, and then you can revolve your shape around like so. Another important pull feature that you might be using in your future models is the sweep feature. And to use the sweep feature, you would need your base shape and your line of reference or your trajectory. And what this basically does is that it pulls an object along a defined path. So first of all, so if I go ahead and first press select my circle so Ansys knows that I'm going to be pulling this, press pull, and then press sweep, and then individually, and then select all of my lines by clicking them once, holding control, and clicking all the rest. I can extrude this circle along a path like so. This is very applicable when you're making piping, and when you're and is very prevalent in, I guess, like heat transfer scenarios. So that's one feature you should look out for. In case you haven't noticed, there is a useful dynamic message bar in Spaceclaim up here and down here, which can basically guide you along every action that you do. And if you're ever stuck, or if you ever want to explore a new feature, you can always just refer to the dynamic message bar to understand what that feature is going to do. Which is why I like to think that Spaceclaim is fairly intuitive and just very simple to get used to. One more feature that it could be important is how you can split a body. on your object. The prerequisite for splitting a body is that you must have a splitting plane or a cutting plane. So to do that, I'm just gonna actually grab this plane, press move, get it in view, and I'm gonna move it down to just like, I don't know, somewhere here in this first object. Okay, I'm gonna have to end my sketching. And I am going to press split body. Split body, if I'm now, to just understand what split body is, I can just read the dynamic message bar, which says to click a target object, which is going to do this. And then it says to click a face plane or edge loop as a cutter. So I'm just going to click on this plane. And as you can see in my structure tree, I have my one solid, the second solid, and then my sort of like pipe up here. And as a third step for split body, you can see right here, it says that you can click to remove any region. So if I wanted to get rid of this top part, I can. If I don't want to, then I can just press escape. And that's how you can split a body. If you want to import specific objects from other Spaceclaim files, what you can do is you can go to Assembly and press plus file. That'll lead you into your file folder where you can look at, you can just find your file and upload it, and it will be introduced right alongside it. I'll just give a brief example, I guess. If I do this, then it gets imported, kind of merged, but I can always just go to move and just I have a big cursor, that's why it's hard to click. Just press move and move it away. That's something you can do if you want to work with multiple objects or just multiple assemblies.
Hi, Shahir. Sorry, just a quick question.
Hey, yeah.
So is Ansys, is there a separate file that I need to open if I want to make a part or assembly similar to SolidWorks, or is it all in this just one type of file?
I believe it'll all be in one file in Spaceclaim. I'm not sure if you can make like rotating like full-on like assemblies like how you can in SolidWorks. I'm pretty sure you can in this tab, but I think SolidWorks has more functionality in that.
Got it. Okay. Thank you.
No problem. All right, so the last thing I want to just quickly go over is how you can measure the dimensions of your object. What you can do is just go to the Measure tab, click on Measure, and just, you can click between two edges, 2 points, etc., etc. Just click once, press Control, click again, and it'll just tell me the minimum distance between my two selections. If you're too lazy to go to the Measuring tab and you just want to measure on the fly, what you can also do is just simply select the two edges once again, and you can see the measurement in this bottom edge right here. But the measuring tool is more useful in case you want to measure areas or perimeters. And you can also use the mass properties to get volumes or total surface area or center of volume, etc., etc. All pretty useful information. So that is about it for the general basics of Ansys Spaceclaim. I think once you start practicing from here on out, you'll be able to pick up even more features that you'll be able to incorporate into your design projects and just become more adept in Ansys Spaceclaim and Ansys as a whole. What we're going to do now is you can take a look at your 8-sheet. I'll also be having the drawing posted on the slides. And what we're going to do for about, let's say, 20-25 minutes is go ahead and make a bracket. Test your skills and exercise your newfound Ansys knowledge. You can start off with the basic bracket without the rib. Then if you're feeling cheesy, feeling a bit brave, you can go and make a rib and then add some fillet features to it. Here are the drawings. And yeah, I'm open to taking any questions in the meantime, or yeah, if you have any questions regarding the drawing, then I'm willing to help out as well. I'm also gonna start making the drawing or making the model about 5 minutes in case you get stuck. So you can have some reference to work off of. All right.
Hi, Shahir.
Hey, hi.
Hey, so basically what we have gone through is that we talked about the basic sketchings and then modelings and CADing of parts, right? Which is pretty similar to SolidWorks. You mind like talking briefly about some of the analysis function of Ansys, just like pointing it in the directions of what it can do and then where we should go, something like that?
Do you mean like where you can go with your modeling?
No. The analysis part of Ansys instead of just sketching and.
So you mean like simulations and whatnot, right?
Yeah.
Yeah. So we actually have a second workshop designated for that. This workshop is mainly specifically for the sketching and the drawing, just the Spaceclaim portion of Ansys. In about 3 weeks, we'll be hosting the Ansys simulations workshop, which will be going more in depth into the analytical parts of Ansys. We'll be going over static analyses, impact analysis, thermal analyses and whatnot, and I'll be just going you through how you can perform those steps based on your Spaceclaim designs and overall just have a more complete project.
All right, cool. Thank you.
No problem.
Shahir?
Hi.
Hi. So could you just explain the split command again?
Yeah, sure.
Just
Okay. So let's see if I can control Z it. Yep. Okay. So in order to perform a split command, the prerequisite for splitting a body is that you must have a cutter plane. You can either make a new plane, or like what you can do, just do what I did, is just drag this plane down here. And if I want to cut it this way, I can do that if I want. Once I have my plane, my cutting plane and set up, I'll just go ahead and go to this intersect tab right here and press split body. And using the split body command, I can first select my object that I want to split up, which is this object right here. And then secondly, I have to select my cutter plane, which I'll just do right here. And then immediately once I select my plane, you can see the body's been split up.
okay.
And if I wanted to, I can just click on it to delete, or if I can just like leave them both there if I wanted to.
Okay, perfect. Makes sense. Thank you so much.
No problem. If you find the bracket exercise a bit, I don't know, too easy, I also enlisted another exercise that you can work on in the H sheet, and you can go ahead online and find additional exercises that you can use to practice, Spaceclaim. I'm going to go ahead and start slowly on just working on the bracket, going over just some of the features that you can use in Spaceclaim in the meantime. Okay, I just selected everything deleted, not everything got deleted, so I'll just go into my structure tree, click on them individually, and get rid of them. All right, so I'm just gonna have to select my plane, and I'm gonna go ahead and make my base. My big mouse is really getting in the way. All right. Just gonna trim away my construction lines because I don't need them anymore, and go ahead and pull this through. Screen the chamfers and make them 16, like in the drawing. Okay.
Sorry, when you do the chamfer, did you click both of the edge or did you just click one? I missed it.
Yeah, so I selected both of the edges. I can
Oh, okay.
quickly go back. Yeah.
All right, yeah, cool. I thought it just like automatically chamfer both, that because I missed that. You probably press Control and select both edges.
Yeah.
Cool.
Okay. Spaceclaim. Just gonna pull up my fin first, about 40. And then I'm gonna select this edge, press pull, and pivot it all the way down, like so. And now you can also, for the remainder of your model, is just select these corners right here. And I believe they were just regular fillets. Oh, whoops, not these corners, these corners. I don't think the dimensions were given, but we can set them as 10 for now. We can go ahead and select these two corners, same thing, make them 10. And that is about it. And that is how you go ahead and just make a pretty simple bracket on Ansys Spaceclaim. I hope that this exercise kind of got you a bit introduced into, Ansys, got you a bit introduced into Ansys Spaceclaim, and if you got a bit of practice with the program. Apart from that, you can go ahead on your own time, work on the second bracket. The remainder of this workshop can just be me answering any questions you may have. If you don't have any questions, then that is the end of our workshop. In about 2 weeks, we have our AutoCAD workshop. So please be sure to come and drop by on that as well. And the week after that, like I mentioned earlier, we will also be having a sequel to this workshop. It will be the Ansys simulation workshop, which will be going over mainly static simulations, explicit analyses, and steady state thermal simulations. So be sure to drop in for that. Thank you all for joining if you don't have any questions, and I hope you have a good evening.
Thank you very much, Shahir.
Thank you.
You're welcome.
You.